at number 1. A cross-section of a right triangular prism is created by a plane cutting through the points, and it's also perpendicular to the opposite base. What is the most specific name of the shape representing the cross-section? Well, let's draw the cross-section. Okay? And it's perpendicular to the opposite base. What kind of angles are formed? What kind of angles do perpendicular lines make? Right angles. So I know those are right angles. Look, these bases are parallel to each other, and these two angles are right angles. What do I know about those two angles? They're also probably going to be what?
Sorry, I can't search the web on Apple Watch.
I didn't ask you to do that. Thank you. So those are more than likely going to be right angles as well. Well, we have a four-sided figure as my cross-section, because the cross-section is a two-dimensional figure formed from when you cut along a three-dimensional figure. Well, which one of these is not a four-sided figure? Triangle. So I know it can't be a triangle. Okay? Trapezoids look like this. Does that look like a trapezoid? Do those look the same? No, not a trapezoid. Okay? So it's either B or T. But which one of those has four right angles? A what? A rectangle. So our answer is rectangle. Can you turn your OST packet? Can you get that out? Follow along, please. Thank you. The cross-section is against a two-dimensional shape that is formed when you're cutting along a plane on a three-dimensional figure. If we take a look at 2, it says a rectangle and a horizontal line segment are shown. What is the resulting object when the rectangle is rotated on the horizontal line segment? Well, what do, whenever we rotate rectangles, a three-dimensional figure, do they always form? What? Very quietly whispered. You are correct. Great, say. Cylinder. Yeah, rectangles, when we rotate them, always create cylinders. Which one of these looks like a cylinder? Cylinders, they don't have edges. They're nice and curved and circular. Okay? Also, is it touching the line? No. So whenever it doesn't touch the line and we rotate it, there's always a gap. So it's going to be a cylinder with a gap. Just in case they ask this question, they had a solid cylinder, an egg, it would still be egg. There's going to be a gap there. Questions over that? If we take a look at number 3, it said a study reports in 2010 the population of the United States was 380,745,538 people, and the land area was approximately 3,531,905 square miles. Based on the study, what was the population density in people per square mile of the United States in 2010? So we want to find population density. How do we set that up? It's going to be a fraction, and you're going to end up dividing. Not necessarily. A lot of the times that's how it goes. But it's a certain thing over a certain thing.
People in square miles.
Yeah, people over the square miles or square distance. A lot of the times the population is bigger than the square miles, but sometimes it's not. So you have to be very careful because you can have a really big space, but not a lot of people in it. So make sure it's always people over population over area. So we're going to put our population in the top and then the area in the bottom. Again, usually it's big over small, but not all the time. There are instances where it won't be. And then you're dividing your calculator. Round to the nearest 10. When we do that, what do we get? And the hard part about this is just making sure you type it in correctly and not miss any digits. Sometimes you type in really fast and forget our digits. Take your time, look at, make sure everything's in there. Divide. What do we get? $87.44, which rounded to near cent would just be 87.4. 87.4. 7.7. And then usually it's already labeled for you, like on the test there will be a box where you put your answer, and then there's something like people per square mile off to the side. So you don't really have to worry about labeling, just worry about getting the right answer. And that's how I have it in Canvas too. So you don't need to label. Questions over that. This last one is a little bit more of a trickier one. Normally, this will just be a normal density question, but I thought it was a good one to go over because it incorporates a lot of other things in this one problem. But forces, Hannah has a cone made of steel and a cone made of granite. Each cone has a height of 10 centimeters and a radius of 4 centimeters. The density of the steel is approximately 7.75 grams per cubic centimeter. And the density of the granite is approximately 2.75 grams per cubic centimeter. What is the difference to the nearest gram of the masses? So this formula is not given to you, but density is equal to mass divided by volume. Whenever you're trying to find density, mass divided by volume. But in this particular problem, what are we trying to find? The difference between the what? Mass, right? So if we look at that formula, which variable are we going to end up solving for? M, right? We're trying to find the difference between the masses, so we want to solve for M. Right? So, in order to solve for M, we need to know what the density of each cone is, and we need to know the volume of each cone. We have to fill in our other pieces. So the two types of cones we have are steel and granite. And we're trying to first figure out the volume. We're trying to find M, let's figure out what the volume is. Because they gave us the densities. So we just need to find the volumes. Okay? So to find the volume, you would look on your green sheet, you would go to cone, and the formula for volume of a cone, 1/3 pi r squared times the height. Write it down. Okay. To find the volume, what did they say the radius and the height of each cone was? What was the radius of each cone? 4. And the height of each cone was what? 10. And this is great because if the cones, even though they're different materials, if the cones have the same exact height and radius, aren't their volumes going to be exactly the same? Yeah. So you just have to find the volume one time, and that's the volume for both figures. So let's just plug this in and round to the nearest whole number. And if you're rounding using Desmos, I think I still have Desmos pulled up. If you're rounding using Desmos, this is how you would plug it in. You would plug it in as 1/3 times 4 squared. Again, if you don't use your keyboard on your computer, here's the squared button. Okay. Times 1/3. Oh, I forgot the pi. Pi is right down here, right in front of there. So 4/3, 1/3 times pi times 4 squared times 10. So if we rounded, that's about 160 what? 168. Okay. So the volume of each cone is about 168 cubic centimeters. So when we solve to find the density of each cone, we don't know the mass, but we know the volume is 168. What's the density of the steel cone? 7.75. So our equation would equal 7.75. Plug 7.75 in for density, 168 in for volume, and then solve for M. How would we solve for M? What do we have to do with the 168? If we're already dividing, what's the opposite? Multiplying. Okay. And then you do 168 times 7.75, and what do we get when we do that? 1,000 what? 1,302. So that's the mass of the steel cone. We repeat the exact same process, but we don't need to find the volume. We just determine that the volumes are the same. So for the granite, we know the volume's still 168. We're still trying to find the mass. So this time around, what's the density of the granite cone? Density of the granite cone is 2.75. So then to get m by itself, what do we have to multiply by 168? Use the same thing you did in the other problem. And m ends up equaling what? What's 168 times 2.75? 562? 462. So are we done with this problem? We found the masses for both, but what did the question ask? The difference. What does difference mean? Subtract, right? So we're going to take the mass that we got for the steel and subtract the mass that we got for the granite. Always do big minus small when you're trying to find the difference. So we do 1,302 minus 462. What do we get? What is it? 840? So the mass would be 840 grams. That's the difference between the masses of the two cones. This is a more complex problem. Okay? I'm not expecting every single one of you to be able to do this. Okay? They have more complex ones and more easier ones. Okay? I just wanted to go over this one because it kind of incorporated a lot of other things. But generally speaking, when it is a density problem, they'll just ask a basic density problem that you'll see. Okay? I just like this problem. I want to go over it. Any questions over that? No? Okay, where's the